Howdy aspirants, welcome to Dr. Sourav Sir's classes, and in this video I am solving CMI M.Sc Math, that means चेन्नई मैथमेटिकल इंस्टीट्यूट का जो पोस्ट ग्रेजुएट प्रोग्राम है उसी प्रोग्राम का जो मैथमेटिक्स का जो एमएससी और पीएचडी एंट्रेंस एग्जामिनेशन के लिए जो रिसेंट पास पेपर हुआ है 2024 का उसी पेपर का सॉल्यूशन. इफ यू वांट टू टेक क्लासेस फ्रॉम आवर साइड और वांट टू टेक डाउट क्लियरिंग सेशन, previous year question solution, mock test, study material, any of that, please don't hesitate. Please call or WhatsApp on this number. Dr. Sourav Sir reply individually through your WhatsApp. So already all you all know that Dr. Sourav Sir's class is the best coaching institution for any type of mathematics related examination. If you want to take admission from our side, this is the best time because now we can provide the maximum discount of this course. Okay, so don't waste time. This is the best time to take admission in Dr. Sourav's classes and boost up your preparation with Dr. Sourav Sir. So let's move on. Question number 6. Question number 6 में क्या बोला गया है? Let x be a subset of R cube where x has a property S if it contains at least two elements and every Cauchy sequence in x has a limit point in x. So pick the correct statement from below. Okay, so how to solve? So given यहाँ पर बहुत सारा स्टेटमेंट है तो कौन सा स्टेटमेंट सही होगा. सो एस का प्रॉपर्टी क्या है? व्हाट विल बी द प्रॉपर्टी ऑफ एस? सो दैट इज वी कैन मेंटेन द Cauchy sequence. A sequence xn is called Cauchy sequence if every epsilon greater than 0 and there exist an index n that is such that for all mn greater than n and d of xn less than epsilon, where d is the represent distance between elements. So here the limit point a point where x belongs to capital X is a limit point of a sequence xn, that is if the sequence converges to x, if the sequence converges to x in R cube. Okay, so thus having property S implies that x is sequentially complete. That's meaning all Cauchy sequence in x converges to a limit point within what? Within x. And now we can analyze option B. So here the option A we can analyze. Now we can analyze option B. If x has a property S, then it must be closed. So how to analyze it? So this proof of explanation here: sequential completeness and closed set. So a set is closed in a metric space like in R cube if it contains its limit points. limit points. And for any Cauchy sequence in a subset X, the sequence converges to point in X, then X must be include the limit point, which is not definition of a closed set, not a definition. So in this case, property is has directly implies any Cauchy sequence within X and has its limit point in X. So therefore, X contains all limit point, that contains all limit points. And now we can find out the relation to coset. Since every Cauchy sequence X converges to limit point X, converges to limit point in X, this implies that X must be a what? Closed set. X must be a closed set because a set that contains all its limit points is closed by definition. In any matrix place including R cube. So here option B is the true for the sequential completeness, that implies a closed set. So now we can check other options also. So first we can check the option A for compactness. While compact sets R cube was closed and bounded, R cube are closed and bounded, so where the property S does not guarantee boundedness, so the completeness is not necessarily implied by the property S, thus A is false. And C and D means if these are the additional conditions about the specific operations on the elements of X that leading to density in R cube, which does not directly follow the definition of property of S. So C and D also false. So further analysis would not be required to check this, but they are not directly like to property S in general sense. So which option is correct here? Option B will be the correct answer for that question. Okay, so if you like this video, please share this video to your friends and your family and subscribe our channel. Do not forget to click on the bell icon also. So that's all about that. We will meet you in next session soon. Thank you.